chapter 12. We're doing the whole thing today. Okay? So the whole chapter 12 is today. That's good in a way because, like, if you are good with the calculator and a couple of definitions, there's like no algebra to do. There's no computation by hand to do. It's just like, do I know how to use my calculator and do I know what this stuff means? And it can be like an exceptionally easy test, or it can be a big zero if you're like, I don't know how to use my calculator.
Well, we have a note card.
Oh yeah, you can still have a note card, for sure. All right, so to get started, so we have a little bit of vocab about polynomials to start. So we say something is a polynomial function if it can be written in the form a sub n to the times x to the n plus a sub n minus 1 times x to the n minus 1 plus yada 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 plus a sub 2x squared plus a sub 1x plus a sub 0. So we call these a subs the coefficients. And these coefficients are all real numbers, and the only exception is that first coefficient cannot be 0. And then we say that the exponents on our variables these guys are all non-negative and integer valued. So no decimals, no negatives, no fractions, but only in the exponents on the variables. Okay, you can have that stuff going on elsewhere. If you look at that equation, the only operations going on is multiplication between a number and a variable, and then exponent of a variable, and then like addition and subtraction of terms, right? There's no square roots. There's no division going on. Everybody's okay? There are two special attributes for functions that we want to talk about. First is the degree. The degree is the biggest exponent on the variable. So in this one, it would be n. And then there's one special coefficient called the leading coefficient, and that's the coefficient attached to the variable with the biggest exponent. In this case, that's a sub n. Let's do a quick little practice, deciding if something's a polynomial or not, and then naming, if it is, naming the degree and leading coefficient. All right, let's take a look here. F of x equals 4x to the 6th minus 5x squared plus 2x minus 1. Is this a polynomial? Yes or no? Yes. Yes, very good. Notice that the only operations going on is multiplication between a real number and a variable. The only exponents are on variables. All the exponents are positive whole numbers. And then the terms are just added or subtracted. That's a polynomial for us. What is the degree for this polynomial? That's the biggest exponent on a variable. And what's the leading coefficient? 4. That's the coefficient attached to that variable with the biggest exponent. Piece of cake, right, dudes? All right, let's look at B. Is that a polynomial? Square root of 3 times x minus 6. leading coefficient, is g of x a polynomial? What do we think?
No. I said
You're all wrong. It is. Why did you say no?
no. So it wasn't all like squares and stuff.
Well, there is an exponent. It just, we didn't write it because we don't have to write exponents to the first.
And the leading coefficient is the largest exponent, right?
That's the degree.
Degree.
So the degree here is, it would be 1. That's the largest exponent. What's the leading coefficient? Square root of 3. Very good. So far, so good. C, is that a polynomial? H of x equals the square root of 9x to the 4th plus 16x squared. No, it is not. Why is it not? Yeah, so the square root is extending over the variable, right? Notice in the previous problem, the square root ends before the x. Here, the square root extends over the variables. That's the difference. So that square root is only on the 3. That's fine. That's just a real number. Here, though, the square root extends over the x's. That's now no longer a polynomial because it's involving an operation on a variable other than, addition, subtraction, multiplication. And since it's not a polynomial, we don't write a degree or leading coefficient for it. How about D? Is that a polynomial? Okay, why did you say no, Max?
Because that, oh no, that one can be negative. I was confused because the second, I thought all the ends were supposed to be non-negative.
They are.
They are, alright.
So this is not a polynomial, and the reason is we have a negative exponent attached to the variable. Now keep in mind, if this was instead like 2 to the negative 1x, that's a polynomial because the exponent on the variable is positive, which is different than 2x to the negative 1, right? Everybody feel okay about polynomial or not? How to pick these things out? We've seen some good counterexamples. One of the ways in which we might name polynomials is based on the degrees. The degrees of the polynomial correlate to the name we might give that type of polynomial. So if we look at the polynomial f of x equals 0, we call that a 0 polynomial. And the degree we have for that is undefined. So anything that's with a f of x equals 0, we just call the 0 polynomial. If we have something like f of x equals a, some constant a, where a is non-zero, that has a degree of 0. We call that a constant function. If our f of x is ax plus b, that has degree 1. We call degree 1 functions. Linear functions, that should sound familiar. And if we have something like f of x equals ax squared plus bx plus c, that's degree 2. We call degree 2 functions quadratic functions. Again, that should sound familiar from last year. What do you guys think? So far, so good? Guess what? That was section 12.1. Do we do any calculations there? No, we just use some definitions, right? That's it. So in section 12.2, we're going to talk about correlation. So correlation is going to describe the linear relationship between two variables. So for example, if I have like this scatter plot, like that scatter plot, and that scatter plot, if we want to describe how linear these things are with the terms strongly linear, moderately linear, and weakly linear, this first graph, we would describe the linear relationship between x and y as strong, moderate, or weak. Strong. Why did you say that? Looks like a nice tight straight line, right? If I look at the next graph, I describe that as moderate. You can tell it's still kind of line shaped, but it's a little bit thick. You know, maybe it's a little wobbly. And the last one we would call weak, because I don't know what that's supposed to look like, but it sure doesn't look much like a line. Hi, Miss Lytle. Thank you. Kiara, for you. Foster, not, sorry. I always forget there's two of you guys in here. All right. So that's relatively easy, but Mr. Kulik, that seems awfully like wishy-washy for math class. Can we make this a little bit more quantitative where it's, you know, we describe this correlation maybe using like a number or something that I could calculate? Yes. So other than just using our eyeballs, which is fine, but we can do better, we can calculate something called a correlation coefficient. We abbreviate that with the lowercase letter r. So a correlation coefficient is a number between -1 and +1. If r is greater than 0, we say there's a positive correlation, i.e. that means positive slope. The data trends upward from left to right. If our r value is negative, then we say that has a negative correlation, meaning we have a negative slope, or the data trends downward as we move from left to right. If r equals exactly -1 or exactly +1, we have perfect correlation, meaning that all the data in that data set, all those points would lie on the exact same line. So you can write one line that would pass through every single data point. And then if r is equal to 0, we say there's no correlation, meaning the data is like perfectly random. Now, in practice, you're never going to see a correlation of 0. It's mostly a theoretical value. But the idea is the closer you get to 0, the worse the linear relationship gets. So let's take a look at a picture here and kind of try to make a description and an estimate here, and then we'll show you how to do this or calculate this value yourself. So it says describe the correlation based on the graph and then give an estimate for the r value. Bless you. So when we describe our relationship, we should say two things: whether that correlation is negative or positive, and then whether the relationship is weak, moderate, or strong.
Moderate.
Okay, is it positive or negative? Good. Why? Slopes down. Good. And then you said moderate. I would say this on the border between moderate to strong here, right? I'll call it strong, in fact. But it's lightly, it's like weaky strong. So we'd say that. That's our description. And then to estimate the R value, right away I know that I'm going to have a negative R value. Why? Because it's sloped down. It's got a negative slope to it. And I know it's got to be between -1 and 0. And I think it should be closer to -1 than it should be to 0 because it's clearly line-shaped. I would accept answers anywhere between -0.7 and -0.9. I think anything in that range is acceptable. Just making an estimate. We're just, because it's strongish, so it should be close to -1, right? The closer you are to 0, the weaker the relationship. The closer you are to -1, the stronger the relationship. So I would say we're definitely on the pretty strong side. But that's why you get a pretty big range of values in there that I would accept if all we're doing is using our eyeballs to make an estimate. Does that feel okay? Yeah. Now, again, Mr. Kulak, okay, you put a number to this, but that's not very satisfying to me. Like, can we actually calculate this number? Is this a number that's calculable? The answer is yes, but we'll never do this by hand in this class. It's beyond the scope of what we're trying to do. Instead, we're going to use our calculator to do this, and I'm going to show you how to do that today. So let's say that this is our data set. This is describing like the different prices for a can of soda pop and the number of cans sold at that price. So if you have your graphing calculator with you, I invite you to take it out, turn it on, and follow along as we kind of walk through this process. I'm going to begin with a step that only needs to be done once. Like, unless you reset your calculator's memory, you do not have to do this step again. But if this is not your calculator that you're using today, you'd have to repeat this step when you get to your calculator so that the stuff shows up that we need to show up. So what we're going to start with is by turning the diagnostic on for our calculator. This allows for the R values to be displayed later on. So to do that, I'm going to press the blue second button and the number 0. That opens the catalog on our calculator. The catalog is an alphabetical list of every command on your calculator. The command we're looking for is called diagnostic on. So I could scroll through all the A's, all the B's, all the C's, all the way to the D's. Or I notice on my keyboard there's little green letters, A, B, C, D, etc. I'm going to press the button with the letter D underneath, or the letter D above it. That skips me all the way to the D's. So that's a lot less buttons to push. I'll scroll down till I find the command diagnostic on. I'll press enter to select that command, and then press enter again so that it says done on my screen. Anybody still working on that? Okay, that's the only time you should have to do that, presuming you're using your own graphing calculator. Unless your memory is reset, you should not have to do that again. Next up, we're going to show you how to make a scatter plot out of our data here so you can look at the picture. And then we'll show you how to get an R value out of that. So it's going to be like 2 steps here. Everybody's okay? All right, so I'm going to begin by entering this data into my calculator so I can plot it. To enter data into your calculator, we're going to press the Stat button, which is just right there in the middle. Once I've pressed the Stat button, I'm going to use the Edit tab and the Edit command. So I'm just going to press Enter. And then I'm going to type in the prices in, well, what I see here is some columns, L1, L2, L3, etc. If I go over, there's more. These are the L stands for list. It's like list 1, list 2. Now I have some stuff in my list. Most of you probably don't have anything in there. If you have stuff in your list and you want to get rid of it, you can delete individual items by moving your cursor on the item and pressing the delete button. Or you can wipe the entire list by moving your cursor onto the list title, pressing the clear button and the down. Don't press delete on the list title. Okay, so I'm just going to delete those out of there, or clear those out of there. And then I'm just going to type my prices into L1 and my quantities sold into L2. Yes, Matthew. Just use L2 and L3 then. You'll have to make an adjustment later on, and I'll show you how to get it back here in a minute, but for right now, just use L2 and L3. It doesn't really make much of a difference. Everything will still work the same. You'll just have to tell the calculator I'm using L2 and L3 instead of L1 and L2, which is whoop-de-doo, no big deal. And at the end of class, if you remind me, we'll go and get the L1 back for you. But it takes a minute. All right, anybody still entering data that needs a minute? Okay. All right, we ready to go? All right, to plot this data, I'm going to press second and the Y equals button. So the blue second button and the Y equals there in the upper left-hand corner. This opens the stat plots menu. I'm going to pick one of these plots. You can plot up to 3 graphs at the same time. I'm just going to use plot 1. I'm going to begin by pressing enter on the on, so the on is highlighted. I'm going to use type 1. I typed my prices into L1 and my quantities into L2, so my X should be L1 and my Y should be L2, unless you're Matthew. If you're Matthew and you needed to do L2 and L3, I'm going to move my cursor down, and if I notice above the numbers 1, 2, 3, 4, 5, 6, there's L1, L2, L3, etc. So I can just do second and the number 2 to get L2, and then second and the number 3 to get L3. So I just need to update things. Now, I didn't do that, so I'm going to put my stuff back, but I was just kind of demonstrating to you that how to change those. And the mark I always use, I like the little square. It's easy for me to see. Sometimes those singleton points are tough to see. Any questions? Anybody still kind of getting their stat plot set? Should have been mostly just ready to go once you turned it on, right? All right, I'm going to exit out, so I'm going to press second and the quit button. To graph this, the best way to do this is to use the zoom stat command. So I'm going to press the zoom button and then scroll down to option 9 that says zoom stat, and I'll press enter. So the calculator's automatically chosen a display window where it's going to fit my data onto it so I can see all my data. I don't have to muck around with like choosing my own window. I'm just going to let the calculator choose a good one for me. So that's our scatter plot. When I look at that, what do you see? Probably strong negative correlation, right? If we were to estimate an R value here, I would probably say somewhere between like -0.1 and -0.9. Anything in there is probably pretty good. This looks awfully line-like to me. You guys agree? Okay. So that's how to get a scatter plot. Everybody's good with that? Okay. I'm going to move on. So I'm going to exit out of here. What I'm going to do now is actually going to accomplish two things at once. So the two things that we're about to do is we're going to calculate the correlation coefficient, that R value, and at the exact same time, we're also going to create a linear model for this data. So it's going to create an equation for a line that's going to fit this data as best as possible. It's called a best fit line. Everybody's cool? Okay. To do this, we're going to press the stat button there in the middle. But this time we're going to move over to the calc tab. Calc is short for calculate. And because we're looking for an equation for a line, the command we want to pick is linreg. That's command 4, L-I-N-R-E-G. And then underneath it, or next to it, you see it's a mx plus b equation, right? An ax plus b equation for a line. So I'm going to do that and press enter. When I do that, a menu comes up. Does anybody have an old calculator that doesn't get a menu coming up when they press linreg? You do? Is it just paste it to the screen? Okay. So hold on for a second, Mariana, and I'll explain what you have to do. So when we typed in our data, we put our x's into L1 and our y's into L2. So I'm going to leave that where it is, unless I'm Matthew, who's going to use L2 and L3. The next option is the frequency list. We will never use a frequency list in our class. The next option is to store the regression equation. This is something we most often want to use. So what this option does for us, it allows the calculator to take the equation we're about to build and save it somewhere so we could use it to do things. So the place that we would want to save it is into one of the y equals slots on our calculator. So I'm going to save mine into y1. So to get the y1 there, I'm going to start by pressing the vars button, which is just below the down arrow. I'm going to move over to the y vars tab. I'm going to select the function option and select y1. And then I'm going to press the calculate button. I'm going to take a timeout here and talk to Mariana here for a moment. What I'm talking to Mariana is only for Mariana, unless you have an older calculator that didn't give the menu that we just looked at, but everyone else can tone out or zone out for a second. Colby.
I got the y1, but how do you get that?
Yeah, I pressed calculate. Okay, Mariana, on your screen it says linreg parenthesis, right? So what you're going to want is you'll want to tell the calculator which two lists you used. So L1, comma L2. So you'll press like second, the number 1 to get the L1. You'll type the comma, which is above the number 7. And then second, number 2 to get the L2. And then if you want to store this into Y1, you'll do another comma. And then you'll do vars, move over to the Y vars tab, select function, select Y1. Yep, which is right below the down arrow. And then you go over to the Y vars tab, select function, and then pick Y1. And then you close your parenthesis and press enter, and you should get the same output that we have here. Okay, come on up. It's okay. Yep. Oh, so you don't even, there's no ring in parentheses. So you just press enter.
Oh, okay.
And then same thing we got. All right. Everybody, we're back. So this is now again for everybody. So what is this output saying to us? Well, if I look at the first line, it says the equation it's written is a y equals ax plus b. That's a linear equation, right? It's the equation for a line. It tells us the a, the slope, is negative 104.6857143. The b, the y-intercept, is 329.2 2857143. It has a value for r squared. We don't know what that is yet. Hang on, we'll get there. And it has a value for our r. That's our correlation coefficient, negative 0.96. So pretty dang linear, right? Everybody's okay with what we're reading here? Okay. Now, let me show you what the store reg EQ option did. If I press the y equals button, I look at y1, look at what's there. Look, it's the equation that the calculator just made for me. It typed it in there all by itself for me with all the stinking decimal places. I'd have to copy anything down to my calculator or my paper and then copy it back onto my calculator. Kira.
How did you get back to the Y1?
I just pressed y equals. Okay, do you see the equation? Everybody see it? That's all that the store reg EQ does, is it saves that answer someplace so we can use it again. So for example, if we press the graph button now on the upper right-hand corner, in addition to our scatter plot, there's our line of best fit. That's the linear model that we just made. So we can see that is darn close fit to the points on our scatter plot, right? Good fit for our data. Everybody feel good here? So, that's weird. So one of the things, what this linear model is really allowing us to do is it allows us to make predictions, right? We've built this model based on this data. And now if I wanted to say, I wonder how many cans of soda I would sell if instead of charging, if I charged 50 cents instead of this, right? So remember when we type this in, our XYs were like price, comma, quantity. So what I want to do is just do like Y1 of 50 cents will return some quantity, right? Like an estimate for how many cans I would sell. So we can do this all in our calculator because we stored our equation into Y1. We can just tell the calculator to plug 0.5 into the equation stored in Y1 rather than like having to type all the numbers in our calculator. Like we could do, the negative 104 point whatever times 0.5 plus 329. And I could type that all out. That stinks. I don't want to do that. I want the calculator to just plug it in for me and be done with it. Everybody's okay? So to do that, I'm going to ask the calculator to do exactly this. I'm going to ask it to do Y1 of 0.5. So I'm going to press the vars button. I'm going to go back to the main screen, actually. I'm on the main screen now. So second in mode to get back out there if you're still looking at the graph. To get the Y1, I'm going to press vars. That's below the down arrow. I'm going to go over to yvars. I'm going to pick the function option. I'm going to pick Y1. And then I'm going to do Y1 of 0.5 and press enter. So that tells us my model predicts that I would sell about 277 cans a pop if I charged 50 cents instead. Everybody's okay with that? What if instead I wanted to charge $5? So I would want to do Y1 of 5. Now, rather than climbing back through all those menus to get to the Y1, I can just move my cursor back up to here and press enter. And then I can just edit, like take out the decimal point. And that saves me like a whole heap of keystrokes, which again, if you want to go back through the menus, that's fine. It's good practice. What came with the error? Was it? Okay, so do you have something in your Y1? If you press the Y equals, is the equation there? Okay, so you must not have stored the regression equation when we did that. When it set the store reg EQ, you might not have had your y1 in the right spot or something. So it didn't save it. So you're trying, the calculator's saying, I can't plug 0.5 into nothing. Like there's no equation there to plug into. So that's what happened. So Blake, what you'd want to do in practice, you don't have to do this right now, but you'd redo the lin reg with the store reg EQ for y1. And then the equation will be there, so you could do like y1 of 0.5. Is that okay?
Yeah.
Okay. So if I did y1 of 5, let's take a look at what I get. Does that number make any kind of sense? No, right? What's that saying? Somehow I should be selling like negative cans of soda. What the heck would that mean? Would that mean people are walking in and giving me soda back? I don't know, right? So put this in the back of your head, because we're going to circle back to this example at the end of the lesson when we talk about like the reliability of predictions. But just because we've made a model and we use it to make a prediction does not mean that all predictions are created equal and they're all equally valid. We'll talk about how to spot potentially invalid prediction later on. Is everybody okay? Now, just for the record, this is ostensibly what people are doing, like, you know, when you make the people that predict the weather, they're essentially creating a mathematical model and based on data and certain inputs, and they're trying to predict, you know, the temperature or the weather or whether it's going to snow or whatever tomorrow. This is essentially what they're doing. Or if you are, you know, like gambling online on sports or whatever, the way they're making their, you know, like the lines, your gambling lines, or your over-unders, or, you know, like predicted win totals, all of that stuff is being done via the same or a similar process where you're taking some past data, using it to build a mathematical model, and hoping to output a future prediction that's pretty accurate. Now for the gambling stuff, there's a little bit more to it than that because there's a financial aspect to it, but like most of the time, this is what all throughout industry, all throughout the real world, people are using data to build a mathematical model in an attempt to make a really accurate prediction, right? This is super helpful. It's essentially being able to tell the future. Okay. So that's it for 12.2. This is the last section here. We're just ripping right through this. What's up? Oh, that would have been the 277 that output from our calculator. Or the 276 point whatever. I just rounded it to the nearest can, since you can't sell half a can of soda. I mean, maybe you could, but like, who's going to buy the other half? Be weird. So yes, give me this half open can of soda pop. Ugh. I'm not buying it. So, you know, if our data looks like this, I mean, it's pretty clear that you'd want to use like a linear model here, right? Like that's what I would be expecting. But what if my data instead looked like this? Or, you know, maybe looked like that. I should probably put some. Or maybe, you know, looked like that. You know, or like that. You know, there's lots of different types of functions that we might want to consider using based on the shape of our data. So if I look at this first one, that's this U shape, what type of function has a U shape graph? Parabola, which are quadratic functions. So maybe a quadratic model would fit that really well. This next one, maybe that's a cubic. This one could be exponential. This one would probably be a power model. Now, I'm sure in your Algebra 2 classes last year, you talked about quadratic functions and cubic functions and exponential functions, but maybe not power functions. So let's take a minute and just kind of describe what I mean there. By a power function. So power functions can be written in the form f of x equals k times x to the a, where a and k are both non-zero. We call a the power, and we call k the constant of variation, or some people call it the constant of proportion. And then if I were to read this equation, we'd say that f of x varies with the 8th power of x. So for example, a power function could be, this, which is the volume for a sphere. So if I look at this, what is the power for this? 3, very good. So that's the A. And what's the K? The constant of variation. Not 4/3 and not pi, but rather 4/3 pi. So it's all the coefficients up front. Is everybody okay there? And if I were to write this in words, I'd say that volume varies with the 3rd power of the radius. So if I wanted to write that in words, I could write it that way. Does that feel okay? Again, pretty simple, pretty easy. So far, so good. Now, if I look at these models here, sometimes it might be really difficult to tell whether the data I'm looking at is linear or exponential. For example, if you pick the right part of that exponential piece, it looks pretty linear, doesn't it? Or if I pick the right part of the quadratic and the right part of the exponential, those could look pretty similar, right? Or even like if the quadratic was upside down, if I picked the right part of the quadratic with the right part of a power, it could look pretty similar. It would be nice to have a measurement that would let me decide which of these options was really the best numerical fit for the data set that I have, since I have lots of other options. Now, correlation isn't going to help you here because, well, if I look at these other ones, they don't look very linear at all overall. So I need something else to do that. That something else is going to be the coefficient of determination, or we call that the coefficient of determination, which we abbreviate as R squared. Remember when we did the linreg, we got that R squared value on there as well? That's the coefficient of determination. Anytime you run any regression on your calculator now, in addition to getting the values for the constants, you'll get a coefficient of determination. And we can use those values to compare two different models to see which one is the better mathematical fit for our data. Right? So r squared is always between 0 and -1. And the closer we are to 0, it's the better r fit. So if I did a ln reg and exponential reg, I could use the coefficient of determination to compare which of the two models really fits my data better. Whichever one is closer to 1 would be the one that I'd want to pick. Does that feel okay? So let's do a example with our calculator where we go and do one of these other models. Okay. It says consider the given data table. Use the data to create a scatter plot. So that's one thing we have to do. And create a power regression curve. Notice that says power regression. It's telling us the type it wants us to use to model the data. Then use that curve to estimate the orbital period of Neptune, which is 4,497 gigameters from the sun. Okay, so there's a lot to do here, right? It's asking us to do three things: scatter plot, power model, and then make some prediction or some estimate. Everybody's okay with that? So to start, what do we have to do first? Enter the data into our calculator so we can create our scatter plot. Exactly right. To enter data into our calculator, where do we go? Stat, and then edit. So I'm going to clear out the stuff that was in there. So I'm going to highlight my L2, press the clear button, and then down. And then I'll start typing in my values. Yes. Okay. So once I have my data entered, I'll exit out of there. And then I want to go to my stat plot. So second, y equals. I'll pick one of the plots. I'm just going to pick plot 1. And it's all still set up from last time, right? It's on. It's picked. It is type 1 using L1, L2, using the square. So I'm all set here. So I don't really have to do anything. I'm just reminding you that's where you have to go. So I'm going to exit out, and then I'm going to do zoom stat. So I'll press the zoom button at the top, scroll down to find option 9 on my calculator, and pick zoom stat. So here's the scatter plot. Notice this extra mumbo jumbo. That's my calculator still graphing that linear model from before, so I'm just going to go and clear that out of there so it's not in my way. So there's my scatter plot. I got a bunch of stuff down here that you can't really see very well, but whatever, I don't care. It's good enough. Is everybody okay? All right, so that's part 1. We did that. Now it wants us to create a power regression curve. So I'm going to exit out of here. And all of my regression equations are stored in the stat menu. So I'm going to press Stat. And I'm going to go over to Calc. And if I notice after linreg, we have a bunch of other options here. There's quadreg, so for quadratics. Cubic, for cubics. Quartix, that's degree 4. We have another version of linreg. Don't ever use this one. Just use the first one. It does the same thing, but for whatever reason, I don't know who uses this one, but it's just like it's the same thing, but we're going to call B the slope instead of A. I don't know why. Don't use it. There's logreg, that ln is for logs. Don't use it for linreg. Some students make that mistake. Exponential regression. And then there's the one I need, power. Right? The directions ask for a power regression, so I want to pick that one. I type my x's into L1. I type my y's into L2, so that stuff's all set. I never do a frequency list. And then we need to do the store reg EQ because it's asking us to use this equation to make a prediction later on. So I definitely want to save it onto my calculator so I don't have to do it by hand. So what I want right here is the y1 again. So to get to the y1, I press vars. I go over to yvars. I pick function. And then I pick y1. And then I'll go ahead and hit calculate. So here's my equation. So like y equals 0.20008 times x to the 1.4996. I'd write, so if I was a test or whatever, I would tell you how many decimal points to write down or whatever, but there's, something like that. Everybody's okay? So I'll tell you where to round at. It's probably going to be a lot of decimal points, so I can make sure you did it right on your calculator. So that's my power model. That's like my answer for 2. And then 3, it's saying, if this is how far Neptune is from the sun, what's that orbital period? So there I'm going to want to just be doing like y1 of 4497. So onto my calculator, I just want to get that y1, so I can go and do vars, yvars, function, y1 of 4497. So I get 60,150.1, let's say. So that's like my answer. Is everybody okay? As a little bonus question, what if we asked instead, let's say, from the sun is a planet that has orbital period of, 7,326 days or something. So for this, it's like we have this number here, and we're looking for the x, right? So we're trying to say like y1 of what equals 7,326. No, because y1 isn't a number, right? y1 is a function, so I don't want to do that. Again, the calculator is going to do this for me if I know how to ask it. So what I'm going to do is I'm going to go to the y equals menu. And in the y2 slot, I'm going to type in this y value, 7,326. So into y2, I'm just going to type 7,326. Everybody's okay? I'm going to hit graph now. So here comes that power regression model I made earlier. Here comes the line 3,000 or 7,326. What I'm interested in is where they're intersecting. To find that intersection on my calculator, I'm going to press second and then the trace button right here on the home row. And we'll pick the intersect command. And now since I have just two curves and they only intersect in one place, I can just press enter 3 times. The inputs don't really matter. So it's telling us then that x value would be 1,104.6. So we would just say that that's how far from the sun that planet would have been. Everybody's okay? So again, if you're looking for a y, you're just going to do y of whatever the x is that you're given. If you're looking for an x, you're going to plot the y and find the intersection with the model. But this is the gist of it. This is the whole chapter 12. Did I have to do one single thing by hand? No. Just use my calculator to do every single numeric thing here, right? Either I read an equation and described parts of it, or looked at the graph and described what I saw, or I typed stuff into my calculator and had my calculator do everything else for me. Nothing is required to do by hand here. In fact, I encourage you not to. So if you didn't have your calculator with you today, or you didn't follow along, or you're just still kind of shaky on the calculator steps, what's the best thing you can do? Yeah, watch the video again, right? You can pause it. You can see my cursor moving around, what buttons I'm pushing on my calculator. You can pause the video while you follow along and like practice again. You can redo certain parts if it's just like, hey, that last 5 minutes I'd like to see again. You know, like take advantage of that. That's why we record these, is so you can use it again, particularly for stuff like this where it's like, like where is this written down, what the calculator steps are. It's not, just watch the video, watch that part of the video again. So we finished chapter 12. You should be able to do 1 through 31. You're like, oh, Mr. Kulik, 31? Most of them are all done in your calculator, right? Or look at it, you know, is this a polynomial or not? Or like, what's the degree? And, you know, like pretty simple stuff like that. Since we finished chapters 12, what might you expect next class? Homework quiz. That'd be, yeah. Right off the bat. What should you be able to do on the homework quiz? Calculator stuff. Okay, you should be able to do calculator stuff. So next class, we'll do that. We'll make our half sheets. We'll do our test review stuff. And the class after that, so that would be Monday, will be, no, wait a minute, today's Wednesday. So yeah, it'd be Tuesday would be the class after that, excuse me. Should be expecting the test. Should the test be a big deal? Not if you can do your calculator. Should be piece of cake. Be the easiest thing you do all semester, provided you're like proficient on using this thing, which is not too difficult with a little bit of practice. If you do the homework, you'll be a pro in no time. You know what I mean? There's no review packet for this chapter because it's just, I mean, it's the homework. So just giving you a heads up on that. Any questions for me about what to expect the next couple of classes? Again, if you have calculator problems, like you're getting errors and stuff and you can't figure out what's going on, yeah, feel free to come talk to me. You know, but if you need the steps run again, like you can watch the video anytime, right? And get those steps run through again. Not that I won't run through them with you, but like if you're at home trying to do homework and you're like, how do I do this again? I'll wait to talk to Mr. Kulik tomorrow. You don't have to wait, man. You can just watch the video. That's what it's there for.